Welcome back, students. In the last part, we learned about work. Now, along with work, another important thing is energy. If we have energy, then only we can perform a work. And now, the energy also depends on person to person. That is, our capacity is the energy. And according to our capacity, we perform that particular work. Now, the capacity of a person differs. For example, a 10-year-old will have different type of energy and a 20, 30-year-old will have a different type of energy. So that means it is the capacity of a body to perform the work. The unit of work and energy is same. The unit in SI system is joule and in CGS it is erg. Now energy can be of different type. It can be light energy, heat energy, chemical energy, kinetic energy and electrical energy, potential energy and so on. So energy can be of various types. Now here we are going to learn two types of energy, that is kinetic energy and potential energy. Let's first talk about kinetic energy. Now kinetic energy is the energy which we get from the moving object. That is the energy which an object has because of its motion. Whenever any particular object is in motion, it is having kinetic energy. And when it stops, it is having potential energy. So for example, a fan, when a fan is moving, it is having a kinetic energy. A bicycle is moving, it is having kinetic energy. A car is moving, kinetic energy. People are running, kinetic energy. So kinetic energy is the energy which is in motion. So the energy of motion that is released from the stored energy, that is called as the kinetic energy. So सारे moving object में kinetic energy होता है. Examples, when an arrow is released from the bow, so when it is flying, that when the arrow is released, that time it is having kinetic energy. When it is going, it is moving. The particular object or a person is rolling down the hill, it is having kinetic energy. We are moving our muscles, kinetic energy is working. A car is moving, kinetic energy is working. The formula for kinetic energy is force into displacement. Why? Because kinetic energy is the work done on an object. So whatever work is done in a particular object, that is called as the kinetic energy. So formula for kinetic energy is force into displacement. But this is not the formula. This is just the thing, that is kinetic energy is equal to force into displacement. Actual formula, we need to find out that what is the formula for kinetic energy, that we will be finding in the derivation of kinetic energy. So indirectly what we can say is kinetic energy is the work done by a force to displace a stationary object through a distance s. So a particular object was stationary and when it started to move, it is moving and then it reached to a particular place. So that is nothing but the work done. So that means kinetic energy is equal to work done and work done is equal to force into displacement. So that means kinetic energy is also equal to force into displacement, that is F into S. Expression for kinetic energy. Now kinetic energy is the energy in an object when it is in motion. For this we are using the formula, that is W is equal to force into displacement, that is S. Now why we are doing this is because work done by an object is always equal to force into displacement. This is our main formula. Then according to Newton's law, we have studied that force, that is here we can put the value as ma, that is mass into acceleration. We have learned in the last chapter that force is equal to mass into acceleration. And according to the second law of motion, if we use second law of motion, S, that is displacement, is equal to ut plus half at square. U, that is initial velocity, is always 0. So S is equal to 0 plus half at square. As 0 doesn't have any value, so we will take S is equal to half at square. Now these two things, that is F is equal to m into A and S is equal to half at square, that we are putting in this formula. So work will be equal to force की जगह पे what we will write now, m into A, that is acceleration, mass into acceleration, multiply by S. Instead of displacement, what we have got the formula for displacement now, that is half at square. So we have got that W is equal to mass into acceleration multiply by half acceleration into time square. We can write it also as work is equal to half, as m we can take out and at square we can put in bracket. So this way we can write, because here 2a is there, 2 acceleration is there. So we will put at the whole square, and we will get this, that w is equal to half m at square. Now here we are using Newton's first equation of motion. Earlier we had used Newton's second equation of motion. So Newton's first equation of motion is v is equal to u plus at. U is the initial velocity, a is the acceleration, t is the time, and v is the final velocity. Initial velocity is always 0. हमेशा initial velocity 0 ही होता है. So v is equal to 0 plus at. So v is equal to at, as 0 doesn't have any value. Now we are squaring both the sides. So on squaring both the sides, we will get as v square is equal to at square. Now we had found out that w is equal to half m at square. So now here, instead of at square, what we can use is, we can use this, as at square is equal to v square. दोनों एक ही है. Instead of v square, I can write at square. at square की जगह पे I can write v square. So here 80 square की जगह पे what we are writing is, we are writing v square. So what we got, that work, this work is equal to half m, and instead of 80 square we are writing v square. So work is equal to half mv square. This we got till here. Then next, kinetic energy is always equal to work which is done. So kinetic energy is equal to work done. So instead of work, that is W, I can also write as KE, that is kinetic energy. So as work is equal to kinetic energy, so we have a work ka formula what we had got half mv square. So instead of W, we can write KE. So KE is equal to, that is kinetic energy is equal to half mv square. And this is how we got the formula or the equation for kinetic energy, that is KE is equal to half into mass into final velocity square, that is half mv square. This is the formula for kinetic energy.